So for this episode of How Do We Wire It, we have in front of us here on this screen a high efficiency hot surface ignition system. Now, hot surface is very, very similar to spark ignition. The only real difference is instead of having a spark plug, which is going to now ignite your burners, you have a high resistance heating element that's going to ignite your gas. Really, the basic operation of your hot surface igniter is it's a highly resistive silicon carbide element. When I apply electricity to that element, since it has such a high resistance, it is going to heat up. It's going to start to glow bright red, and it's going to generate heat. Your hot surface igniter gets hot enough to ignite the gas that's coming out of the burners. So how are we going to wire such a system? Well, here we go. Again, here's another pictorial diagram of a standard simplified hot surface ignition furnace. Okay, so we have our L1 and L2, which is our power source. We have a door switch, transformer, thermostat, a blower, BN, fan switch, our safeties here, pressure switch, high limit switch, rollout switch. We have our vent motor, which is again our inducer motor. We got our combustion air blower motor relay, which is what controls our vent motor. Obviously, it's operated off of a 24-volt coil. Here is our igniter, okay, or ignition element, i.e., sometimes is what they're called in diagrams. And then you have your gas valve. So, in order to wire this, we're going to do it very similar to spark ignition. I'm going to come out of my L1, and I'm just going to come down into my door switch. My door switch, aka, is known as my dummy switch. Okay? That door switch has to be closed in order for anything else in the system to work. So I'm going to come out of my door switch. I'm going to power up my my primary side of my transformer. Out of my transformer, I'm just going to bring that right back to my L2, just to complete that circuit, so it's out of here. Okay? So again, everything, source path switch load. Okay? Break your diagrams, your schematics, anytime you are troubleshooting any piece of HVAC equipment, break it down into smaller, bite-sized pieces. Once you're able to do that, you are able to understand wiring a lot easier. Okay? So, anytime we're dealing with wiring, focus on your loads and focus on what is controlling that load. Okay? So we have a couple of things here still that need to have 120 volts brought to them. I got a blower fan and I got a vent motor. But what do we need to have and control those units, those loads? We have a fan switch. Our fan switch is a temperature actuated switch. Okay, there's the thermostat, right? It's a thermostat, thermostatically activated switch. So as temperature rises, as it goes up, that switch will close. I want my fan switch to be the switch that's going to control my blower fan. So how do I do that? All right, well, I'm going to come out of my door switch. Okay, I'm just going to go this way because I think it's a little easier to do. Okay, I'm going to come up. Again, I'm going to come down. I'm going to go right into my door switch, or my fan switch, sorry. Out of my fan switch, I'm going to go right into my blower fan, just like that. And to complete that circuit, I'm just going to bring it right back to my L2, just like that. Okay, so again, there's your source, your path, your switch, two switches, actually your door switch and your fan switch are two switches wired in series, and your blower fan. So where else do I need to go? Well, I still have to take care of this guy, my vent motor, also known as my inducer motor. So I need to be able to have my combustion air blower motor relay control this guy. So in order to do that, I need to again bring my power from my door switch. And again, we're just going to go like this. Come down. I'm just going to go straight over down here like this. Okay. And I'm going to bring it right in. Okay, there's my relay. All right. Come out of my relay, and I'm going to go into my vent motor. Okay, out of my vent motor, I'm bringing that right back to my L2. Just like so. Okay, so what we just did is we just took care of the three main loads in our furnace. We took care of the primary side of the transformer, we took care of our blower fan, and we took care of the vent motor, also known as the inducer motor. Okay, so what do I need to do with the rest of this? Okay, well, I have my safeties, my roll-off switch, my high limit switch, and my pressure switch. Okay, I have a 24-volt coil, and a majority, if not all, of your residential, light commercial heating units, all of your pressure switches, all of your safeties are going to be wired with 24 volts. 24 volts is our control circuit. Okay, so where am I going to be getting my 24 volts from? My 24 volts is going to be coming from the secondary side of my transformer. So I'm going to come in and power up my transformer. Okay, so now what I need to know and what I need to understand is that my thermostat is my temperature sensing device that is in the space. It's what's going to close and tell my furnace that, hey, I need heat. But I need to make sure that my safeties are wired correctly so that I can have a safe working unit. So I have to do and understand my sequence of operation with my furnace. I got to understand how things are working. What does my rollout switch do? What does my high limit switch do? What does the pressure switch do? Okay, well, the pressure switch is a very important part. Okay, it's just like the name states. It's a pressure switch. It's sensing pressure. Okay, usually your pressure switches are going to be what is going to sense the pressure difference inside your heat exchanger. It's going to tell that furnace whether or not your heat exchanger is clear of any sort of debris, any sort of non-condensable gases. It's going to tell us whether or not the heat exchanger is actually solid or is it cracked. Okay, our high limit switch, that's going to be a safety that's going to shut the furnace off if the furnace gets too hot. Rollout switch is going to sense the flame. It's going to sense whether or not the flame is rolling out in the wrong direction in the furnace. So how am I going to accomplish this? Well, I have to actually do this off of my W, off of my thermostat. And I'm going to actually wire my safeties and the coil on my relay here in parallel. Okay, so I'm going to come out of my W just like this. And I'm going to send power right here. Boom. I'm going to send it right to my pressure switch first. But I'm also going to take another wire and I'm going to come down and I'm going to energize the 24 volt coil on my relay. Yeah, now you might ask yourself, why did I do that? Just hang tight. I'm going to explain it to you in a second. So what we're going to do is now we're just going to complete my coil. Okay, I'm just going to take my power out of my coil here, and I'm going to send that right back up to my transformer so that I have a complete circuit. Right? Again, source, path, switch, load. Right? My secondary side is my source. Here's my path. All right? My red wire is my path going into my switch. Okay? Down to my load, my coil, right? And then back. So, why did I just take my two wires out of my W and go in two separate sections? Well, in order for me to get my vent motor to turn on, I got to be able to energize the coil. Okay? So, once my thermostat closes, I am now going to send 24 volts down to this coil, which is now going to close those contacts, which is now going to make my vent motor, inducer motor, start to spin. Once it starts to spin, and I sense my pressure difference inside my heat exchanger, and it's telling me that everything is good to go, that pressure switch is now going to close. If I was to wire this pressure switch in series with this coil, how would I be able to energize this coil to make this vent motor work? I wouldn't be able to, because this is a normally open switch. It's only going to close in a pressure difference. Okay, so the switch actually has to be on its own circuit, parallel. So I'm going to take that pressure switch and I'm just going to simply wire it in series with my high limit switch and my rollout switch. Okay? Like so. I'm going to go just like that. One right after another. That's my safeties right there. That's my safety circuit. This guy right here is so important to the operation and the safety of my furnace right here. Now, do I have to wire it? Pressure switch, high limit switch, rollout switch? No, I don't have to. I could do it another way. Oh, sorry. Let's take that and let's put that back, shall we? Yeah. Okay, let's come back. All right, that's got to go up there like that. I can also take it and go another way. I'll show you right now. Okay, I can take this wire and I can go the other way. Again, all they are safeties. So I can come out of my W if I wanted to. I can go through my roll-off switch first if I want. Then I can go through my high limit switch. I can go through my pressure switch if I want. It does not matter. They're switches. Just as long as they're in series, they're good to go. Okay? So out of my pressure switch, I'm now going to send that wire down to my ignition module on my 24 volts, just like that. Okay? So now in the event of anything that happens with this furnace, if any one of those switches happens to open, vent motor happens to fail, the pressure switch is going to open. If I have a high temperature problem, gets too hot, high limit's going to pop. If I have a rollout, that's going to pop. If any one of those switches happens to open, I'm going to kill the 24 volt circuit down at my ignition module. And when that happens, I'm going to kill my ignition sequence. Okay? In this case, it's going to be the gas valve. Depending on the ignition module itself, that 24 volt circuit can kill the entire thing. It's all different models out there that will do different things. But I'm killing my ignition source, my gas. Okay? Because remember, when it comes to combustion and ignition, you have your combustion triangle. You got to have three things in order for something to light. You got to have air, fuel, and spark, or air, fuel, and heat. If I take away any one of those three, I'm not going to have ignition. So if I de-energize my gas valve in the event of a safety problem, I just took away one of those three in that ignition triangle. I took away the fuel source. It's not going to do anything. It's not going to light. Okay? So I'm going to come out of my 24 volts here, and I'm going to go right back up to my common on my 24 volt side. Right there. Okay, I'm just going to go right there, just for neatness. Okay? I'm also going to have to send 120 volts down to my ignition module. The reason why this particular type of ignition module has an L1, L2 down here is because my hot surface igniter needs 120 volts in order for it to operate. So I'm going to send 120 volts. Okay? I'm going to send it right out of my door switch. And I'm going to come down. Right into my L1. My L2 is I'm just going to send it right back to my L2. Coming up. Let's go right back. Okay? My hot surface ignition is very simple. All I'm doing is just taking the two wires that are connected to it, and I'm just going to plug it in. Just like that. My gas valve is just the same thing. It's just going to take the wires and I'm going to plug them in. Come down. There you go. Okay, so really, sequence of operation of a hot surface ignition system is very, very, very similar to a spark ignition system. The only difference out of the entire thing is your ignition source, whether it's a spark or a silicon carbide hot surface ignition system. So really, sequence of operation for this unit is really once the thermostat calls for heat, I'm going to energize my relay coil, which will now energize my vent motor, which will now start to spin to clear out any sort of combustible gases that may be still inside the heat exchanger. It's also going to prove whether or not I have a clear flue pipe and a intact heat exchanger, simply due to the fact is that I have a pressure switch that is in there to sense that pressure difference inside my heating unit. Once my pressure switch closes, it is now going to send that power down to my ignition module, telling the ignition module that we do have a call for heat. The ignition module will now send that signal out to our hot surface ignition, our hot surface igniter, which will then begin to glow bright red. After a couple of seconds, probably somewhere around anywhere between 15 and sometimes 30 seconds, the gas valve will now open, and when that happens, the gas will make contact with that hot surface igniter, and it will ignite. Once the burners are lit, the furnace will begin to heat up. Once that furnace reaches somewhere around, again, probably about 140, maybe 150 degrees, somewhere's in there, my fan switch will now close, which will turn on our blower motor. One thing that I do want to add to this diagram is a lot of your modern and more recent hot surface ignition furnaces, high efficiency stuff like that, may not necessarily have a temperature actuated fan switch integrated on the furnace itself. Some of your modern stuff now is an integrated timer that will now turn the blower on. You're usually located on the circuit board itself is a set of dip switches. You just set the dip switch to either 10, 20, 30 seconds, and based off of time, that switch will now close, and that's what actually brings on the blower motor. So there are different variations of units out there. You just kind of have to look at the wiring diagram and look at the wires to kind of see what actually brings the blower on, what timing and what brings on my hot surface igniter. The same thing applies to your hot surface igniter systems. Usually these types of furnaces have a pre-purge setting. Pre-purge just simply allows the vent motor to run for a certain amount of time before it moves on to the next sequence of ignition. Sometimes your pre-purge sequence can be 10 seconds, 15 seconds. So after about 15 seconds of runtime, it will now go to the next sequence in the operation, which will probably now ignite the hot surface igniter. That will begin to glow red, and that usually stays on for another couple of seconds, usually maybe another 15 seconds or so, and then after that runtime, the gas valve will now ignite or open, and then once that happens, the furnace usually will sense that flame, and then it's usually runtime, and it usually will work until the thermostat satisfies. And then once the thermostat actually satisfies, the vent motor will shut down because the coil on side my relay here will actually de-energize, which will open those contacts, de-energizing my motor. Once that motor starts to slow down and stop, my pressure switch opens, and it just kills the 24-volt signal down to my ignition module, which virtually just shuts everything down. So, and that's how you wire a hot surface ignition system.